On this episode of WarDocs, we're joined by retired Air Force Chief Master Sergeant Jason Robbins and Lou Oberndorf, former Air Force officer and current CEO of Operative Experience Incorporated. Our guests discuss their experiences in military medicine and the evolution of medical simulation technology. They reflect on the lessons learned throughout their careers, the importance of simulation in training and evaluation, and the need for advancement in medical education to address physiological disparities. The conversation also explores the role of AI in healthcare, the unique considerations for military simulation, and both guests share leadership lessons for future generations in military medicine. For further information about Jason and Lou, as well as our previous guests, visit our website at wardocspodcast.com. Be sure to follow WarDocs on your preferred podcast platform and subscribe to our WarDocs YouTube channel. I'm your host, Dr. Doug Soderdahl, retired Army urologist.
Welcome to WarDocs, the military medicine podcast. This show brings you a first-hand, behind-the-scenes look into the mission, unique opportunities, and deployed experiences of the entire military healthcare team. From state-of-the-art hospitals in the United States to the most austere environments across the globe, WarDocs has you covered.
Today, we're privileged to welcome retired Air Force Chief Master Sergeant Jason B. Robbins and Lou Oberndorf, the CEO of Operative Experience Incorporated, to WarDocs. Gentlemen, thanks for joining us today.
Doug, thank you very much. On behalf of Operative Experience, OEI, we're really proud not only to be a sponsor of WarDocs, be introduced to WarDocs, but to have an opportunity to talk about something that's very, very important to us and very real for us, and that is combat medicine and how do we train and how do we fight to get our warfighters ready for what they're going to encounter. And so we really appreciate this opportunity.
Well, absolutely. And Jason, I know that you spent a significant part of your career wearing the uniform of the Air Force, and your career path from emergency medical technician and paramedic to special operations independent duty medical technician is really inspiring and unique. What would you say, looking back, was the most significant lesson you learned about providing medical care in those high stress, austere environments that really kind of informs what you're doing today?
Yeah, well, let me start off with saying, wow, it's been an incredible journey, right? I had the opportunity to serve, humbly, had the opportunity to serve with some great teams over the course of my 30-year military career. And I would say, walking away from it as I've transitioned, the one thing I'm probably the most proud of is the fact that as I look back retrospectively, there's not a decision that I would second guess or I would change that led me to be in the position I'm currently in right now. So that speaks volumes because I didn't always do things perfectly. Even in my most difficult times, I just remind you, I served 5 years geographically separated from my family. That's a heavy toll it takes on an individual. And that doesn't take in consideration the 1,000+ days that I was TDY or deployed. So a long period of time away from the family. And I'm happy to say that I'm here today. I'm happily married to my high school sweetheart of 32 years. I have two children, one of which is carrying on the legacy of her family, serving as an air traffic controller at Ramstein Air Base today. And I have 5 grandchildren. So, the fact that I've been able to do everything the way that I did, and I ended up in this current position, I'm perfectly happy with where I'm at right now. I did my first duty assignment was Minot Air Force Base, North Dakota, and that in itself could offer some challenges, as you might imagine. Uh, as a young medic, I was very aspirational. I took a very keen interest in emergency medicine. And when given the opportunity to do so, I elected to go to paramedic school. I was kind of still not 100% sold on the Air Force as a career. 20 years seemed like a lifetime away. I was really looking at the here and now and things that really appealed to me. So I really went to paramedic school to put myself in a position for that exit strategy to become a civilian firefighter paramedic. And as I said, like most medics, I was really an adrenaline junkie. Took a great interest in that emergency medicine, and I was just trying to be the best medic that I possibly could be. And you asked me specifically about any lessons that I learned during that tenure that kind of shaped who I am today. I had a very influential paramedic instructor. Again, it's 1997, so I'm like 22 years old at the time. I'm 10 foot tall and bulletproof, difficult to break through. But this gentleman broke through to me, and he reinforced the importance of what a paramedic's role is. It's really controlling chaos. And when everything around you and everyone around you is going crazy, as a paramedic steps into that picture, it's their role to take everything down a notch and really lower the RPMs, right? That, along with, up to that point, as an EMT that the Air Force trained me in my basic medic school, we hadn't really had a whole lot of experience with administration of medications. So that whole part was new for me. And I really took very close attention to detail on the importance of that responsibility, the responsibility to my patients. Not only it's not just administering a medication because an algorithm says to do it, it's the science behind it. Now, there were for a period of time when I was at my most sharpest, there was probably 100 drugs that were floating around my head, which I knew the mechanism of action, the indications, contraindications. I knew it cold because in a time of crisis, I had to be able to respond appropriately and provide the correct medication. So, you know, throughout my military career, I constantly sought things that would challenge me because I found myself punching above my weight class several occasions. Because I constantly was leaning forward into those opportunities. And I can vividly recall one specific opportunity as I was flying. My follow-on assignment was Scott Air Force Base, flying air medical evacuation. And at that point in time, we had the C9 Nightingale CONUS redistribution mission, right? So we were bringing casualties in, distributed them around the military and civilian medical facilities around the United States. But as most young airmen do, I had the opportunity to sit in my senior NCO's office. And at that time, it was Master Sergeant Charlie Cole. He later became the CMEF, Chief Medical Enlisted Force. He was a senior medic for the entire Air Force, and he served underneath General Green's tenure as the Air Force Surgeon General, the 20th Air Force Surgeon General at that time. But I vividly remember, even to this day, sitting in his office, I look up on his wall and I see this plaque, and it read, for all the places you've never been, for all the soldiers you've never saved during the time you were never here. Young aspiring medic. I'm like, hey, tell me more about this job. And he was very quick. Yeah, I can tell you some of the gross motor movements of what that job entailed, far forward medicine, operating independently, flying in helicopters, but he really couldn't tell me about the intricacies of the soft mission, right? A lot of that at that point in time was classified, if you will, and not open for discussion. But, I was interested in that job immediately. And I don't know, and I still don't know to this day, I'm still close friends with him. If he was, when I asked to do that job, he said, "You're not ready yet." All right. So immediately I took a hit. I'm ready for everything, right? I'm 10 foot tall and bulletproof. Um, but Charlie looked at me and said, "You're not ready yet." And I, like I said, I don't know even to this day if he was protecting me because A, I really wasn't ready yet, or B, he understood the toll that that would take on my personal life. And he understood that I was a family guy. I've got kids, I got young kids. And he knew in his current time in that particular assignment, it took him away from home to the point where it may have upset the dynamics of his family. So after several conversations later, and what I think it was probably a year later, he endorsed me for the job. And I got that same plaque on my wall now, right? Um, but I went on to IDMT school, which was one of the most challenging things I had done at that point in time. Very intimidating environment. We often compare it to it's the only enlisted practitioner in the Air Force, right? So we're operating at a independent provider level as a independent duty med tech, and I was able to get through that, and I followed on to an assignment at Herbert Field, and that's where my time in AFSOC started, was 2003. And you asked me what specific lessons I learned to be able to operate in those high stress environment, and it really always comes back to being ready. And that being ready was multifaceted for me. It was not only being ready in my skills, but being ready in my mindset. When you step on that deployment and you're getting ready to, go into the game, if you will, you want to make sure your mind's clear. And my wife was able to provide that for me. She took care of the household. I didn't have any distractions. When I was downrange, my head was down and I was focused on the mission at hand. So being ready with my training, being ready with my mental state, and making sure my equipment was ready. My equipment was essentially my tools of the trade. So I didn't take that responsibility lightly either. And, that was one thing the airvac really taught me, is pre-flight of your equipment. Before you step to the mission, you're always pre-flighting and checking everything. So I took that initiative. I memorized my equipment. I knew how much I had. In the dark, I could open my ruck, my medical ruck up, and I could grab an IV set. I could start an IV under limited light. I was at the top of my game, and AFSOC did a very good job of training me in preparation to do so. I consider that assignment was a privilege to serve in that opportunity and really support the special operations mission was monumental in my life. Being part of such great teams, even to this day, these are friends of mine that I could call upon. We're a very tight knit group of folks. But I hope that answers your question. I hope that tees this discussion off very nicely.
Absolutely. And I want to start off saying, thank you to your family. There's really no greater patriots than the family members of the service member, because they sacrifice a lot. And, in your case, you were gone for 5 years, and that's an amazing service to the nation that's not recognized. So thank you to you and to your family. So Lou, you've been around in medical simulation for a while. In fact, you helped bring one of the early ones, the Gainesville anesthesia simulator, to market. What was it about that early technology and simulation that you saw as a kind of a quantum jump for medical education? And what were the limitations at that time, and what you thought, back then? Did you see yourself where you are now?
Well, yeah. Now you know. Now you can see and hear and know why J. Rob is one of my key executives. Just listening to that story, I learned something about J. Rob just now, listening to him. Let me back up before medical simulation. I spent 11 years active duty in the Air Force as an avionics officer. I came out in the mid '60s, late '60s. 11 years, and then stayed about 20 years in aerospace. So that was most of them, avionics officer, electronic warfare, program management, that kind of thing. In the early 90s, my job at a big aerospace company called Loral Corporation, it's called L3 Harris now, is the legacy. The defense industry was looking at areas outside of defense to take their technology. I'll just give you the genesis of all of this. And my job at corporate headquarters was to go out and canvass our various operating divisions to see what technology they had, what ideas they had to go commercial. And one of the areas that all of the defense companies in the early 90s looked at and thought it was an appropriate or a lucrative area to go into was healthcare. Part of my job was to go out and find these ideas. Along the way, I discovered this anesthesia patient simulator. It was invented by a team of anesthesiologists, software engineers, biomed engineers, et cetera, at the University of Florida Med School. And I saw it, and previous to that, I had overseen the sector at Loral that was in simulation. And as I've said over the years, simulation, while new to healthcare, was not new to us in the defense business. We understood that. Loral at the time was one of the one or two largest simulation user training companies in aerospace. So we were comfortable with the simulation, but when I saw it in a medical healthcare environment, it lit me up. And proceeded then to license it on behalf of the corporation on a royalty type agreement with the University of Florida Med School. Put it in Sarasota, Florida. We had an operating division there, and we put it there to see if they could incubate a commercial business. A defense company trying to incubate a commercial business. After about 2 years, they'd had as much fun as they could stand trying to do that, and they were going to walk away from it. Healthcare and education and commercial was just beyond them. And I purchased the product line because I followed it. It was one of my favorites. And I followed it because I thought it was so important in healthcare to be able to simulate and to be able to train. Because I understood the power of simulation and training. And healthcare is mission oriented, mission aligned. Do whatever you have to do to get the job done and to save lives, and that's always resonated with me. So we started Medical Education Technologies, METI, and we took this simulator, and we then began to commercialize it, and starting in 1996. What I discovered was that healthcare in general, subset military, had never simulated healthcare training. I used to tell the story, I still do, that if you were to have entered Harvard Medical School, to use a name that everybody can recognize, in 1990, you would have been taught the same way they had taught it for 100, 200 years. And they really had not. It was really you follow somebody around and you learn from a mentor, et cetera. Today, to quickly span the gap, if you were to enter medical school, a nursing school, combat medicine, San Antonio, what have you, type of operation, anywhere in the world today, you would find this technology, simulation in healthcare. And this industry is only if you will, in 1996. We were the first to really go commercial. We had a one or two competitors, and they fell by the wayside. Now there are competitors everywhere because the industry has grown. If you think about that, it's less than 30 years to see an industry. So the first adapters were really medical schools. We were challenged and we wanted to grow our marketplace, and we were determined that nursing education could handle the technology. By the way, the docs didn't think so. The professors absolutely didn't think so. And we were just desperate enough to prove them wrong. So we went from medical schools, put it into nursing schools. But very early in Medi's life, because of my previous aerospace experience in simulation, military simulation, I understood Orlando. I understood the PEO stride, where all the development of simulators are done, because we had been working with them. So one of the earliest initiatives was to introduce high fidelity medical simulators into the military. And one of the concepts that we had early on was that we would recreate the electronic version of a healthcare version of a battlefield. We've been training and fighting. All the services have their ranges and that type of thing. They've been training like that for 30, 40 years. Medical was never a part of that. Healthcare was never a part of that. So that's what led us to go into combat medicine or military medicine. Again, one of the standards that we have, as even from the early days of Medi and now really concentrated at Operative Experience in combat medicine, is that healthcare is healthcare. A patient is a patient. And that trauma patient, that soldier, that warfighter is a special kind of patient. But you basically still have the fundamental physiology, you have the same fundamental treatment, etc., adapted for a chaotic environment that Jason just talked about, the ultimate chaos environment. So we always understood that, and we were determined to take it to that area of healthcare, but in a specialized way. So we've pursued that as a mission, as a life mission now for the last 30 years, and continue to innovate and what have you to advance that practice.
Yeah, that's really interesting. And Jason, going back to what you were talking about, your early training, you were involved very much in the tactical operational part of providing care at the point of care. But then you moved on to become senior medic for Air Force Special Operations Command, and you're now at the strategic level. And you're looking at the training of the people that are coming behind you. What led you to believe, or what kind of led you to see, hey, we need some simulation in training, and what was the gap that you saw that could be fulfilled with simulation versus waiting to do it for real?
I was at a tremendous advantage. My advantage as a senior medic is I was a junior medic in AFSOC. So I had that experience to fall back on. Unlike other services, AFSOC, they do not have a career SOF medical. They flow in and out of the command, and if you're lucky, you might get a follow-on assignment back to back. So the most you're going to see is someone with maybe 6 to 10 years of experience. Now, some of our surgical teams are a little different. Special operations surgical teams, they spend a little bit more time in the command, but even our pararescue community, the other side, the more tactical side, they have a conventional CSAR mission, so they kind of come in and out of AFSOC as well. So, as of the time that I retired in January of 23, I was not convincing enough to the Air Force Medical Service to put heavy value on the importance of having that background. All too often, our MAGCOM at AFSOC gets lumped in with it's a MAGCOM, whether it's ACC or AMC. And the unique thing about AFSOC specifically, as the senior medic, as the E9, there's only 3 E9s for Air Force. Air Force Chief Master Sergeants in AFSOC. They're one of each of our medical groups, at Cannon and Hurlburt, and then the one that sits in the ivory tower, if you will, up at the headquarters of Air Force Special Operations Command, Surgeon General. And, when I go and represent, or at that point in time, when I went and represented on the Joint Medical Enlisted Advisory Council, I'm one of the senior enlisted medical advisors to the SOCOM surgeon on all things medical and AFSOC. So that background and be able to break through those cultural barriers, if I didn't have that experience serving as a junior medic, it would have certainly put me at a deficit. Now, the reason why I bring that up is because I continue to see it as a problem. I think it's a problem still to this day, and hopefully Air Force Medical Service will eventually put enough importance on managing that talent within the command to bring them back into the command and lead and enlisted and even at the SG level. You know, in SOCOM, as I sat on that panel, one of the biggest training disparities was how soft medics were trained. You got your SF medics, the Army, they're training at Joint Special Operations Medical Training Center up at Fort Bragg, and you got the Navy's doing their Special Operations Tactical Medic at Stennis. And then you got AFSOC, it's got PJs, they got their PJ pipeline at, Kirtland and San Antonio. And then you got the AFSOC IDMTs, which were kind of a hodgepodge of everything. We were able to stand up the Special Operations Center for Medical Integration and Development at UAB Birmingham. We have a tremendously great relationship. Our surgical teams were in there as well. So we benefited from that educational opportunity. And, each of those senior enlisted medical advisors on that SOCOM board, we saw value in creating a soft baseline interoperable standard. Like, what is the standard across all components that we all should be measured by? And we built that. We were the architects for the 35029, which was a SOCOM directive, and it was signed by the CG, and it blessed it off. So what that did is it established what that baseline training should be. The thing it did not fix is that we should all train at the same location. So if we can't train at all the same location, we have to have a mechanism to bless each of these respective courses. And I took that responsibility very seriously as the senior medic for AFSOC. And although we were able to build the document, I think we didn't really get across the table, across the finish line on what that ATP requirement is. So I think they still struggle with it today. I've talked to some of my those that have followed on behind me, and I think they're making some inroads. But I tell you what, I think we all collectively agree that the cultural barriers of the joint environment can be somewhat challenging. At the end of the day, the medics are going to figure it out. When they're downrange, those relationships are going to be built. I mean, I remember as a junior medic stepping into a mission brief, and I've got a SEAL medic right here, and I got an SF medic on the team right here, and we're all building this plan together. We fix it downrange, but what the headquarters element could really do better is codify what that requirement looks like. Like, how do we train to that standard? I think they'll get there. It's just going to take some time. And, relatively speaking, SOCOM is the newest COCOM on the street. So in regard, our medics today are doing a phenomenal job. They're doing great work. They're smarter, faster versions of us. Now, you asked specifically how I believe that simulation, what I think is key to solving some of our training problems. I think simulation crossed a lot of different things off for us on that list of, how do we prepare a medic to go down range, right? Well, first, it provides a safe environment where a junior medic can go in and they can make mistakes. They can make mistakes and they can fail forward, if you will. They can learn from their mistakes, to be debrief. You can reset the simulator and put them right back in. I often compare it, as I'm trying to justify it to my flying partners. It's kind of the flight simulator for medics. Just like you wouldn't expect a new pilot to jump in an aircraft full of people and start doing emergency procedures, you should never expect a medic to jump in that same situation on a real patient where there's potential for catastrophic consequences. Now, the other thing I think it fixed for us specifically in SOF is it kind of bridged that gap of the live tissue aspect. I think the political sensitivities of live tissue training, the challenges of the tremendous amount of oversight that it requires, and just how hard it is logistically, I think they can do a lot of things in a simulated environment that they were otherwise using that particular training adjunct for. Sims are safer. I think sims are certainly safer than using live role players. I mean, if you drop a simulator, you may damage it, but you're not going to injure a live person. And I think additionally, just doing medical procedures like IVs and tourniquet placement, it's much more of a safer environment to really use those tools as they're designed as just simulating them on a live role player. And I think lastly, it really serves as an opportunity to validate the medic's ability. It puts them in an environment where someone can objectively look at how they're performing. And I know specifically in Air Force Special Operations, our tactical operational medical skills lab, where we're using our female simulator and male simulators right now with great success, is they're giving that unvarnished feedback to that member. You're good, you're go or no go at the station, and then falling on giving that feedback to their leadership, as this guy's not quite meeting the mark. This guy might need a little bit of training. I mean, that was a really difficult discussions we had with some of our junior medics when you tell them they're not ready to go down range or they need some additional training when they think they're at the top of their game.
Yeah, it's a great point that you make, that, where the rubber meets the road, they figure it out. The parochialism in ivory towers, it's there, and we wish we could, break that red tape and really get a standardized curriculum and, standards for everybody that work. But we figure it out, and I'm with you. I'm hopeful that we can do that. let's kind of fast forward to, kind of the current situation. And one of the things that surprised me a little bit was a report that I saw that said that women injured in combat had worse outcomes than male counterparts with similar injuries. And one of the hypothesized explanation was, well, do we focus just on male trainers, and do we focus, not recognizing that there's a difference? And I know that your company has come up with a female simulator. Tell me how that happened.
At Medi, we had the first pediatric simulator we brought out. We did have a female simulator. We had a birthing simulator in civilian medicine. We set out to do the combat medic for the male, which is where everybody in the industry has gone. I mean, we used to have 6 foot male mannequins, dress them up like a female, and that was female. That was everybody understood that didn't meet standard. Everybody understood that, but nobody did anything about it. As I understand it, and then maybe Jason could bring out the report is when they did the study of Afghan and Iraq casualties. What they found out was that, among other things, hemorrhage control was the number one thing that they had to deal with. But they also realized that female soldiers, wounded female soldiers, just were not treated. And our medics weren't up to snuff, if you will, up to standard treated. Now, that surprised us as civilians. But we set out to do something about it because we had some ideas, and we teamed with PEO Stride in Orlando. They put out an SBIR for a modular female simulator. Well, we always had that experience, but we said, okay, we'll attack that. We won one of those SBIRs, and eventually we won through combat stage. We were the prime contractor. What we set out to do, we wanted to build an anatomically accurate female. So we went to the government specifications that defines a female soldier to the T, physiologically, size, anatomically, etc. It wasn't just going to be a plastic mannequin. So we set out to do that. We brought the clinical experience to that, and then we partnered with PEO and co-invested with them along the way to finally bring that female soldier to completion. To which this past year, PEO Stride Program Office went through all the T&E, all the development tests, et cetera, and they certified the OEI simulator. It's the only medical simulator that the military has actually taken all the way through DDE&E, all the field testing, all of we hit all the wickets to be certified as the only female simulator accredited by the United States Army and consequently the rest of the force. One of the things that we found out along the way, which surprised us but didn't surprise us if you think about it, we have been taught socially to be very, very careful of how we treat a female. And that barrier, social and psychological and physical, carries through, and we shouldn't be surprised, but it carries through to how to treat a wounded female. We found out through our DT&Es and various testing, and it shocked me. I thought, well, okay, I understand a male medic may have problems with that. We found out that female medics had a problem with it. There's that, and of course, in treating combat medicine, there's something with the wounded soldier. You have to get them trauma naked. Well, that just is all the synapses were flashing with people from what we've been trained. So we had to overcome that. That was one of the. I think that's the real breakthrough that the Army and consequently the rest of the force have now. We're able to overcome that, and I'll let J. Rob talk about why that's important to our medics. But that's how the female medic came about. Full partnership with the DoD, development testing, all the right things, all the wickets, etc. And we brought all of our clinical experience to the table, so that our female and our male mannequin, by the way, are identical inside. What do we mean by that? All of the electronics inside that drive the patient they're identical, male and or female. They sit in a different body, but they're identical. That way we were able to leverage user interface, leverage supply chain, leverage maintenance and training, all of that across the line, so that a male and a female, OEI male and a female, sitting alongside of each other, you run them the same way. You just have a different patient, a more realistic patient if you're dealing with a female. J. Rob, you want to add to that
Yeah, no, I think you hit all
from a
the
clinical standpoint?
high points. I think it was just instrumental in conditioning our new medics. Largely, that's where the problem resided, and breaking those barriers of modesty for the patient, and understanding the importance. In order to do a good trauma assessment, the patient has to be naked to be able to identify the different wound patterns. And I think what the study really showed was that females were not getting that assessment that they deserved because of that modesty piece. I think this is largely testimonial because we're getting tremendous amount of feedback from the 25 medical simulation and training centers that we currently have these simulators deployed to, and then the 103 different locations around the Air National Guard that are currently using them with great success. The problem is we won't know that it actually worked until we get that follow-on post-deployment study. We'd like to think that this is going to be the fix. I think it's actually going to help to have an anatomically correct model to simulate off of, but really we won't know until the next conflict when we get that study back. Yeah.
I will tell you, Doug, on a global basis, this female mannequin being certified with the look and the feel and what have you is absolutely lighting up interest around the world. Both in every military situation, every government that we talk to, that female absolutely jumps to the top of their interest. It really is, and that tells me as a business guy, but whatever, that's a real breakthrough. It was needed. We delivered it, and it really, and the marketplace and the community has really responded.
So kind of broadening the scope a little bit and looking at the overall medical simulation market, J. Rob, you mentioned a little bit about, and Lou, you did too, we kind of started simulation in the aviation industry, and you can put a pilot in a simulator and their vital signs can go nuts because they're in that and they're experiencing a real thing. I'm a surgeon, and I've been waiting to, as a surgeon, be able to train on a simulator and feel like I'm operating on a real patient. And I know that's a goal, but where are we currently in creating that lifelike, hands in the body realism, haptic feedback, high fidelity? How close are we able to get the surgeons and the medical healthcare professionals having that same feeling that those pilots have when they're stressed out to the max in their flight simulators?
So I'll kind of harken back to my early days on the mannequins, the dummies, if you will, that we trained on. They just laid there. You laid there and you simulated everything. Everything was giving you feedback from that instructor over your shoulder, like your pulse is this, your blood pressure is this, and you're trying to do everything you possibly can, but it's really a unrealistic environment. What we've done, we've been really mindful, and we listen to our customer and what they actually want, just like you're highlighting, on how can we make this more real. So I think we have done a phenomenal job of having anatomically correct pulse points. We're getting that feedback. It's an environment where the student can be heads down and get all the information from the simulator itself without having to ask, is my hemorrhage controlled? Is my bleeding, what's my blood pressure? And all that comes to us from the simulator. I think we're at the cusp of the next thing is going to be the integration of virtual reality, augmented reality, where you actually have that headset on, where you can kind of get spatially disoriented. I mean, I watch my grandkids play with this VR today, and it's a step above any video game that I've ever played. So if we can take that technology and overlay it onto our simulator, I think that is the next decade or 20 years from now that we'll potentially see. But Lou, I'll defer to you for what you think the next latest and greatest thing is.
Well, one of the real benefits I think we have at OEI is our founder, Dr. Robert Buckman, is a retired emergency surgeon out of Philadelphia. And the original ideas around operative experience, which he founded, was to hands in the body, so that you actually had organs anatomically correct and touch and feel, et cetera. And you could use instruments, regular medical and surgical instruments. That hasn't gone as far as perhaps it needs to reach a standard or stable kind of repetitive environment, repetitive simulator, et cetera, where the surgeons mostly have gone to is really the minimally invasive. That was the first place they've
Right.
gone to. with and that was
robots and laparoscopic
robots,
stuff. Yeah.
interventional radiology,
Yeah.
interventionalists, and stuff like that. And then again, with augmented reality or virtual reality, you're getting the haptic feedback. But the problem with any of those kinds of simulators, and we're not as far along as I don't see us as far along as what you would want to have as a surgeon. But we have ways to be able to at least supplement. It's the haptics. It's all about the haptics. You're a surgeon, you know that. I've talked to surgeons and they're talking, and they can be tying knots without even looking, and it's just the whole haptic feedback, and that's the thing that that's why the minimally invasive surgical area sector was the first one to really have surgical trainers, because you literally were using real trocars and real handles, and you could get that feedback, that force feedback of the haptics. That's the real problem. Until we could actually get fleshy bone and be able to reset, that's the other problem. I mean, the idea is that you have a case and you have well, you've been practicing on, surgeons practice on chickens and, the original surgical science kind of company. So we're not there. I don't know. I don't see it. We don't attend a lot of surgical meetings now, so I'm not up to date on what's happening there. I know the minimally invasive. I think the augmented or the virtual reality is probably going to be the shortcut to that. But I will tell you, Doug, I don't know if that's real. I'm not a surgeon. I've watched them and they get it, and okay, yeah, that feels right. But every surgeon has a different feedback on the haptics, et cetera. And I don't know that with the augmented or virtual reality. I think that's probably where we're going to end up, or we're ending up. And I don't know if there's that breakthrough like there was 30 years ago with a mannequin patient.
So one of the things that I think we're seeing as kind of the key topic right now in medicine is how is AI impacting how we deliver care, and
Yeah.
I'm sure that AI has some impact on maybe the next big thing in medical simulation. How are you guys using AI in how you see the future in your world of simulation?
Well, first of all, with AI, we're trying to understand it like everybody else is trying to understand it, and it's a moving target. Trying to really understand the depth of it, and the power of it. And I think more that we're probably going to be using AI, and we're looking to using AI in terms of how we make our scenarios and our reactions of the patient, the simulator, more realistic, more authentic, to actually get a feedback mechanism with using artificial intelligence. I think artificial, if we're an education company, so the training company, artificial intelligence is going to be a huge step forward in terms of creating curriculum, scenarios, etc. I think the physical technology is going to have to catch up with AI. AI is moving faster and setting a bar out there faster than the physical guys can get it. You look around now and you see avatars. You see on the augmented or virtual reality, et cetera, and the avatars. That AI is going to enhance that and accelerate that application. I think that's an area that AI is going to, in the training and education. In terms of how you're going to train clinically, I guess Chat GPT. This is my situation. What have I got? What are my options? That kind of thing. I think eventually, medicine is going to get to that point. Although we're not experts in that area, I think that's where AI. But for an education and training, a feedback mechanism combined with physical as well as a virtual reality or augmented reality, I think the interaction of those, I think, is where AI is going to have its first impact. Like anything else, every company, every application, every product you look at in your regular life, everybody's stamping it with that AI, approval. And if it's got AI in it, it must be good, etc. Ignore that because they don't know either. They're just it's like organic. Everything's organic, right? The food you go to the market, everything's organic now. Well, I saw a box of cereal. It used to be frosted flakes, and it's got organic on it. I mean, come on. So I think the AI thing is going to be I think it's going to give a lot of false promises, et cetera, for us at least, but we're trying to understand it, and it's moving faster than we can get that we can keep up, quite frankly. I mean, and it's moving faster than any of us could keep up with. But that's where I see the application of AI, where we're going to try to really understand it and incorporate it.
You know, the military is a primary customer for simulation products, of all types, not only healthcare. And you guys have, definitely a leg up, because with your experience, I wouldn't even know how to spell PEO STRI or what in the world that stood for. But what are the unique considerations when you're dealing with developing stuff for the military, especially with simulation technology, compared to education and training in civilian hospitals and civilian, the Harvard Medical School?
We come at it from both ends. As I said from our beginning, our philosophy was a patient is a patient is a patient. And if we build it for the civilian market, which was the beginnings of Medi, the University of Florida, anesthesia, et cetera, that's a much larger market, a civilian market on a global basis. So we had to attack that. But we always believed that if we got that right, it would have an application in military or now combat medicine. Now you go from the other end with the warfighter in a trauma situation, which is the ultimate trauma situation, the ultimate chaotic situation. You've got to have a different mindset. And how you apply that healthcare and that clinical and the physiology and the op tempo of treating that patient is far, far different. Maybe the closest you can get to it is a big city ER, knife and gun club. Maybe that's close, but that's with us, that goes on all the time. That's constantly. And when you're in it. So I think that's a major difference. You've got the government regulations, you've got the government specifications, the development, all of that process is just part and parcel of dealing with the government in development. So you have to understand that. You have to understand the procurement regulations and rules and stuff. So on the administrative side, you have to understand that, and I think we do because we have a lot of government experience. But you have to also understand that it's a combat medicine. It's not just emergency medicine, and there's a difference, and we understand that. One of the things that the military gave us that I didn't have 30 years ago. 30 years ago, I didn't have a roadmap as to where I could take this technology and what I want, applications, et cetera. So we really basically had to make up the roadmap as we went. And we were blessed. We worked hard, and we did it correctly. It worked. What the military has given us is this TCCC protocol. By the way, PEO STRI is the program executive office. Those are the guys that do all the development work. You'd have a PEO of the F-35 and a tank and a gun. You have a PEO, program executive. That's what the PEO stands for. Turns out STRI is the training and the training side of the PEO, program management. In any case, they gave us a roadmap. We didn't have to imagine or take chances. What we basically did at OEI, as I said, for the first time in my career, I had a roadmap of what the user and where the user was going and where they wanted to go. And so I said, okay, we know how to do technology. We know how to do simulation. We're going to take this roadmap with the requirements and the terms to train the task and what have you, train the standard. And we're going to take that and we're going to take our technology and develop it exactly along that roadmap. That was the major difference. And you had to understand the military and the military procurement and development environment to then realize this is what you had. We had a roadmap, and that's what we did. And to this day, as a result, again, the OEI, the portfolio of products that we have in applications is the only end-to-end TCCC equipped portfolio of products. We didn't make that up. We listened to the customer. He told us what he wanted. He told us what he wanted and how to do it. And when we went out and did it, that's the difference between military and civilian. At least in our experience, healthcare simulation.
So, in medical simulation, you basically are the end user is a human being, and you're trying to get them to become better at treating whatever they come in contact with. What is the biggest gap currently in making the changes that you want in that end user human? Is it technology? Is it the curriculum? Is it the user interface? Where is the gap that needs to be bridged to get our humans better understanding what they need to do in these trauma combat casualty situations in austere locations?
What I see as the gap, if you will, is it exists in the experienced, competent simulator operators. Like we've created the environment now. It's now how do they use that environment to enhance the training and build that muscle memory, if you will, in those medics. I don't know how we get there. I mean, we do a phenomenal job of showing the when we install the simulator, we demo how the simulator works, and we have the DHA TCCC approved injuries that are built into our scenario. But how do they actually incorporate that? If you've seen one sim center, you've seen one sim center, and largely the ones that are really successful are the ones that have been doing it for a while, and they've built that core group of competent sim operators. It's not a set it forget it technology. It takes some practice to be able to integrate that into your training curriculum.
It's our responsibility to make it user friendly. I mean, from a technology standpoint, if we don't make it user friendly, it isn't going to get there. And I think caring about the customer and being there when they need them, I think is probably as much is as important as building up that residual training. If they know we're there to back them up and they don't have to go down on time or down on classroom, et cetera, that's a service thing. But we've got to make it user friendly. Our user interface is intuitive so that they don't have to think about it. Early on, we have phenomenal physiology. The healthcare simulation, but one of the major things even from the very, very beginning is they modeled the entire human physiology. It was so complex as human physiology is. And we kept saying, well, we got physiology. This is the Medi days, and we still have it. We have physiology. And we found out that most healthcare providers probably had forgotten more than they ever learned about physiology. So what we had to do is we almost had to put it behind the curtain. It had to react appropriately, et cetera, and then teach them about why that was happening from a physiological, rather than having to guess. Early days, they had to almost change it on the fly. I I I haven't run into any healthcare provider that knows is that good. So that the automation of that, I think, is really a critical gap. And by the way, that gap it closes, but it never completely closes. It's a constant quest of ours to try to make it user friendly, clinically accurate, physically anatomically correct as much as we can make it, and then give them the results and make it again user friendly.
So you guys made that critical identification that genders are different, and having simulation for male patients and female patients is super important. Is there any other demographic or physiological factors, age, size, pre-existing conditions that future simulators will need to incorporate to make that training even more realistic and impactful?
Well, those already exist. This industry would not have advanced as far as it has if a lot of those issues had been resolved, and we did it at Medi, et cetera. When you model the physiology and you have the physical patient, you could begin to manipulate. You could program that patient with all of the issues you talked about: age, gender, health, healthcare, health industry, experience, history, and then you could create a scenario on top of using that patient. That exists. This industry would not have matured as fast as it did if that was not there, because it's automatic. So a lot of that. Now, when we get into combat medicine, we get into female soldiers, when we get into wounded soldiers, then we begin to adapt from like J. Rod's experience and all of our people's experience of what that looks like and what that represents. And we can adjust the physiology and the physical reaction of that simulator to emulate, if you will, the actual wounded soldier. Jay, you want to add to that at all? Or?
Well, I think that you kind of hit on it a little bit there. I think the follow on, as we're looking at how to best utilize these simulators, are the lessons learned. What are the injury patterns they're currently seeing? And I think that's the advantage we have as such a small company, is we have the ability to listen to our customers to evolve our product to meet what the demand is. But really, I think that's the next level. We look at these joint trauma system studies on what the injury patterns are, how if there's a need out there that we're not currently capturing with our current product line, then we'll have to evolve our simulator to meet that need. But I think right now we're by and far we're meeting all the requirements, at least for the Teachable C requirements that we're focused on.
Doug, we drive technology. We always have. It's in our DNA. As I said, we understand we're comfortable with technology, we're comfortable with simulation, and we're constantly learning about the healthcare piece of it.
So, can either one of you share a story, maybe from feedback that you heard, or some other report that gives us an idea of what a real world example of how high fidelity medical simulation actually made a measurable impact on some outcome, whether it's in training or in real life deployment, pre-deployment? Tell us a story or a feedback that you've got from somebody who's used a simulator and it's made a difference.
J-Rob?
Yeah, well, first thing I'll focus on, I'm not sure you're familiar with the Walker dip principle. Have you seen it? If you've heard of it before the study, it was,
we talk about that all the time
yeah, yeah. I
on
mean,
this show.
we find ourselves in, I mean, again, I keep saying we, like I'm still servicing. I'm not servicing, it's their problem now. But I think what we see is in between conflicts as those skills erode, the only way to really get good at combat trauma is to do combat trauma. And I think we found that to be evident in the later days of OIF and OEF. The first, wave, we were seeing casualties by the numbers that we weren't expecting. And, we got ahead of it. We got smart. We adapted our medical system. We built a whole system of hospitals, if you will, across the battle space to be able to get after that. But my concern is now we're in that, we're in between conflicts. So what happens, and then we take a knee, we kind of get complacent and our skills erode. So I think what we're seeing now is, and I don't think I can 100% answer your question, but we've got organizations such as the Air National Guard who have taken the initiative. They're deploying the simulators all around their unit level. So whereas they would typically have to go to a combat readiness training center or a major location to get their training, they're able to do their training at the unit level. So I think what that will do is, if used properly, will allow them to prepare for what that next conflict may be. And I think all of my regular Air Force counterparts, they need to take that. They need to heed that. I mean, there's not a more important time than now to train for the next conflict. I know you and I, we share our same colleague, Steve Cum, when he was serving as the Air Force Chief Medical Enlisted Force Senior Medic for the Air Force, he used to say things like, spin up training will just make you dizzy. It doesn't prepare you. Just in time training is just too late. So we got to work hard. We, again, the service has got to work very hard to get after this problem now and not be reactive.
One of the things that folks who have gone downrange and have taken care of the combat injured is, sometimes you just see things that you can't unsee, and healthcare providers are coming back with, profound mental changes because of what they deal with. Is there anything that simulation can help with to maybe figure that out and make it less of a problem for when the next generation has to go downrange and see just incredible devastation and maybe feel like they can't take care of everything that they see because it's too much?
As a medic in the unit, I was in charge of training for the unit I was in here at Hurlburt Field, and I'd get these new medics come back, and they'd be talking about all this stuff they learned, all these things they learned, and I'm sitting there thinking, like, well, that's awesome. I mean, you should always learn something while you're deployed, but that's not really the place to be learning, right? So how do we get ahead of that? What did you see? What can we do? I'll be 100% honest with you. I don't think there's anything we can do that'll prepare you for things that you may see in those particular instances. But what we can do is, the first place you see a traumatic amputation, it shouldn't be on the battlefield. It shouldn't be where you are the one looking down at that patient. You're trying to figure out, how am I going to control this hemorrhage or treat this injury pattern. So I think we do a phenomenal job of capturing that in the clinical environment, exposing them to simulation so they can see that. They can go through the muscle memory of how it is to apply in a tourniquet, what the appropriate pressure points are, and transition to a junctional tourniquet and use of hemostatic agents and stuff like that. And then there is an application. Again, I will never advocate for what we do as simulation replaces actual touches on a human patient. But I do think it's a bridge. So I'm not going to cut loose a junior medic who's never done a procedure and let them do it on a real patient where there's catastrophic consequences, but I'm going to allow them to practice and hone their skills to a point where they feel comfortable. And more importantly, the proctor or the preceptor feels comfortable as they do that procedure on a patient in a, you name it, trauma center around the United States, or even in a live tissue scenario. So again, I don't think we can actually prepare them for what they see, but we can help present them with, we can get ahead of the training curve, if you will. So it's not the first time they see these injury patterns.
Are there any other ethical or moral dilemmas that you see in the world of simulation as we get more and more realistic and more lifelike? You know, are there guardrails from ethics that are important to kind of keep in mind when you're developing the next technology?
that's, that's a tough one. I, I got to look. Wait a minute! I got to turn around and get my Bible out here and read that a little bit. And I don't mean to make light of it. I don't think so. I think what we do is we try to take an existing situation, duplicate it as best we can, replicate it as best we can, maintaining that there are moral guidelines, but I don't know that in our career that we've actually had to deal with those kinds of things. I think the closest we would have come to it is with the female. I think that clearly presented some barriers to overcome. I think we've done that, but we did it consciously. Again, anatomical, etc. We didn't exploit that. But we didn't make it neutered either. I mean, we try to make it as real as possible with respect. The way we even treat our female simulator in our plant and where we treat it with respect. I think that's as close as I could come to, perhaps touching on your question. We treat that female mannequin with respect because of that, because of we're really are conscious of the need to do that. That's about as close as I could come to that.
Our audience at WarDocs consists of a lot of current leaders, future leaders in military medicine, and so one of the things that I always like to ask our guests who have distinguished and remarkable careers is if there was one leadership lesson that you'd want to leave with the next generation, and kind of considering our audience of future leaders in military medicine, what would be maybe that piece of advice or lesson that would be important for them to take home?
I'll start with my foundational principles that kind of guided me throughout my career. I made it simple. I'm an easy guy. Trust, training, and teamwork were my three T's. Trust that that I'm going to be trained to to up to the task. Trust of your leadership. I think our leadership, our line leadership, they make a lot of decisions based on knowing that there's competent medical providers in the area to buy down the risk of combat. Right. I think having that trust of your patient is important. The patients, sometimes when I say patient, in my case, as an independent medical technician, my patients are those walking around me. We're a small team far forward, so I don't know who my patient's going to be, but it's probably going to be one of the guys that I'm, watching movies with that night, or playing cards with. So getting the trust of them, so they feel comfortable with you as an independent, because there's, as you might imagine, as an independent duty medical technician, as an enlisted practitioner, a lot of times, and if they don't have that trust, they're like, "Can I talk to the doc?" Well, I'm all you got, brother. Right. So having that ability, then the training aspect, I think throughout my entire 30 years, every day was a training day. Right. And just like I've highlighted, I didn't wait for the opportunity. I had to actually take the initiative to make sure my training was up to the tasks. And then, teamwork aspect, I even live by this principle today. I don't make any decision without the buy-in and the input from a team. So I think that's very important, especially if you're going to be operating downrange in those high risk environments. I think one of my senior mentors, again, back to Chief Cole, this guy was a very impression. He made a very solid impression on me even to this day. And I rely on him for sound advice whenever I'm up against a tough decision. But he always said, no one of us are as smart as all of us. Right. So don't try to make a decision heads down with only the information you've got. Let's bring the team together. Let's huddle before we decide to step to the game. I think the other inevitability that we're up against is, you can do everything right and still have bad consequences. You can do everything right. Your training could be top notch. You can have all the best equipment and your patients may still die. I think that's the inevitable consequence that we deal with in this level, this work that we're in. Um, I think one of your previous guests, General Friedrichs, he actually made the statement and said, when The hallmark of a great leader is when presented with the dilemma of mission first or people first, a great leader will be able to do both. Right. Right. So, last and most certainly, the most important is keeping that focus on the patient. Everything we do should be in the best interest of enhancing the survivability of that patient. And I think if that means challenging the norms and try to solve problems, I mean, as a junior medic, I would often see we're doing something and I would get that, well, that's the way we've always done it. Well, I challenge those that are currently in that environment to make headway. Any good leader is going to welcome the input of a junior person. I think having the opportunity to explain to them what they did and why something failed, so they can kind of pivot their focus. But I welcome the opportunity to be able to get that input from those that are around me to help solve tough problems.
I go back to my time as a squadron commander in Thailand. Young captain, first time I'd have been in command in a squadron, et cetera. And I guess it translates very serious. I mean, you take care of your folks. Like I tell my guys, troops eat first, and then you figure it out. And but on a more broad macro basis, as I've watched over the last 30 years of military medicine and then combat arms, I wish the silos could be broken down. There is a gap between defense medicine leadership and combat medicine, in my opinion. I've watched it, but as far as leadership, troops eat first. Take care of them. Be honest with them. Straightforward. And don't ask them to do anything you wouldn't do yourself. I mean, that's a standard. We've all written the books. We've all read the books, but put it in practice. And we tried to at OEI. I don't know if J. Rob agrees or not from a leadership standpoint, but I think so. I hope so, at least. And if I'm not, you got to let me know, J. Rob. So this is like a intervention here with Doug. Okay. So, I mean,
that's right. We got you here. This is it's not a podcast interview; it's an intervention.
Oh crap!
Yeah.
Well, hey, we've been speaking with Chief Master Sergeant Jason Robbins, J-Rob, and Lou Oberndorf on WarDocs. Gentlemen, thanks for sharing your experiences, your insights. Really, thank you and appreciate your service to our nation. And we really appreciate the support that OEI's provided for our WarDocs program and project. So thank you all for your time. I'm excited to get this one aired.
Well,
you're welcome.
And I appreciate everything that WarDocs has done for our community in capturing the oral history of military medicine. Thank you very much.
Good. Thank you.
All right.
Thanks, Doug.
Thank you for listening to WarDocs. We sure hope you enjoyed it. WarDocs is a nonprofit organization supported by donations from listeners like you. Please follow and subscribe to our show on whatever platform you consume your podcasts, and rate and review this episode, and share the show with your contacts on social media. Find out more information about our show, our guests, and how to become a member of Team WarDocs on WarDocsPodcast.com. Thank you for your support. If you like war stories and medical drama, WarDocs has you covered. Spread the word.